that you need to have information for the infrastructure. The infrastructure is the base. You have a turnout, and combination of turnout, you have some control and command stuffs that manage the train direction, and these things is directly connected to the physical infrastructure. And that is where I want to come back to. It's, when we are talking about BIM model, we are there. BIM model is mainly that. But we need also, if you have some infrastructure, not just want to have some digital mockup, we need to transfer information about these things, physical infrastructure, to the control and command stuffs. If the information is not good because BIM model is not good or not sufficiently have enough information or non-shareable information here, we have some problem there, we have some problem there. And finally, people don't have the time train. So it's basically, the problem is that. And as you can imagine here, many industries involved in that. It's not only one. So the issue of open BIM for us is how the yellow, what you see here in the vertical line is about this information. It's about many industry, many software, many database, and each bus is, each bus here may be software, maybe database, maybe process, maybe people, maybe organizations dedicated to one process. So if they need this information, if there are one provider, technology provider anywhere, one thing we need is what is the added value of this box. We need to in information, we need to know exactly what is out. If not, we cannot manage all that. Railway system cannot be manageable. So we have a really big issue on that. And the open BIM issue for us is to make this information available. That means that we need to discuss with the technology provider. We need innovation. That's clear. But we need also to know exactly which is added value for which technology. To know that what is in, what is out. If not, we cannot follow the process. We cannot integrate the railway. And by the end, we need to develop more and more software in layer to overcome the fact that we don't have the right information in the really comprehensive process. So we need this this open format for really this objective. That is really fundamental for us. So that is the key message of my presentation. So now I will go back more detail to the BIM program. Basically what we are doing in sharing reference object, we put in place reference library railway in the French railway system that's called BBOBIM, with the objective to share with all stakeholders. And inside this object, we have our own requirement around this object. And this is available naturally in open format. To don't say to people to use one tools and another, let the choice to have the real performance, because what we need is the performance of the function we need to reach. You can use any software you need, but what we want to use the right information and to output the right one. And we also use in consistent with the French strategy on BIM. We have a BIM level 2 approach right now. That means that many people can use HIT software because you have many domains, and each domain have expertise that we need to be sure that is the right one for the system. And this information share to integrate it in kind of common data environment in the center. And we choose one, but there are no, that is the core of the problem. And we launch also around that a new project called Minerve, and to railway system about engineering of system. We cannot do the good railway system without managing the requirements and the engineering of the system. So we are involved to create or to adapt existing tools for the railway requirements. So we launch a program around that to test and to create and to share some tools, some requirements about what we need to make an system engineering of the railway and be sure that we can manage the requirement, we can manage the performance of the system, the cost of the system, and to have a traceability when you have some BIM mockup at the end, why you have this state of the model is depend of requirement you have at the beginning of the process. So we do that for this reason. And a few words about digital continuity. In the digital maturity of the software, the pupil, we have some workflow, as we have some BIM for conception, construction, we have a platform, basically BIM level 2, and to share and to organize the process. And for the digital twin, we have to deal with many databases to integrate or to also have a roadmap on that. And this, we do it in parallel. We basically now we are doing experimentation, and we make confident on what we can do to make the system right and the BIM deliver the performance expected. So that, if you would, you have the presentation. I don't take the progress of the BIM at SNCF. We have some infrastructure, IT infrastructure in place. We have training that now about 950 people involved on that, who are involved in at least one project. And we have some many activities around change management and so on. And we have about 150 projects managing in BIM, more or less depending of the requirement we want to put in BIM. And we have many use cases dedicated and specific to the railway operation, to not just have the BIM team and one side and the real team who works on the project on the other side, really to avoid that because it's not cost saving. And yeah, about construction, we are just reached to the first BIM project who reached the construction phases, and we are doing something also to prepare how we can bring BIM to the field. If you are interested in that, I invite you to scan this code on LinkedIn. You have shown a video. The idea is simple, is we are people who don't know exactly what's ongoing, what is prepared in the field, and how we can bring information on BIM of these guys directly in the field. So we do some experimentation on that. It's really promising. And the idea is to get the commitment of the work, the construction people, and not easy. But if you have simple tools, that is possible, and that we can show on this video. We also have some implementation on BIM maintenance. If you are there in 10:30, I have one presentation on that. We have experimentation, and what is about here is to make on maintenance sheet how BIM can help to plan maintenance. So that is about the talk I will have now, and to present more in detail this experimentation. By the end, the digital twin, we are working on it, but with use cases we are working on. If we have digital twin for what, how we can manage the requirement of the system, and which is the main use case can bring value on the system. We make some experimentation on that, and progressively the idea is to make more and more use cases and to progress on and develop capability of the digital twin, just focus on the performance that can be bring on the system, not to make the digital twin with everything on it, with the issue to manage we have so many information, but we don't know exactly for what. And what is the initial requirement that is managed to the state we have in the phase, and to the system you have to manage, and the objective you want to reach. So for this, basically, for the digital twin, the approach is also really to bring this in the basic system engineering approach. You have some requirement, and you have some function, and each function you can develop component for that, you can develop software, you can develop database, or you can put just in place real process. And by the end, you have some state, basically, of your digital twin. You can read the traceability between the state and why this is there, and which is the initial requirement for that. And the idea is to have some digital twin based in 3 layers. The resource layer, which is the ground of the information you can manage to deliver service. Operation layer, that is really about we use information to run Tram, donc how we can deliver service for that. And by the end, how we can deliver service to the end user and the customer. So that is basically idea for around that. We are working on it. Is always an ongoing work. So just to conclude to that, I explain why the open BIM is a conviction. We show that is really a need. We need people who are working with us, with the French railway ecosystem to share. We need to share that, and we need also to make our meaning clear and why we need this. It's not just a position, it's a need. Because we are moving to, in the context where we have more and more constraints, we cannot just use more and more software, more and more software layer. It cannot efficient, we cannot manage information. And by the end, we lose the control of the system. We need to keep the control. And to keep the control, that means that any initiative, software, database, and so on, we need to know what in, what out, to have the qualification on that, and to place it in the system engineering, to put it in the function we need to reach in the railway system in the world. And I also make an overview of BIM progress at SNCF and the future, what we are working on right now. If you have any question, that ends my presentation. Thank you.
Thank you. Thank you very much for a very interesting presentation. Now it's good time to make questions from the audience. Is there some question from the audience? Mercedes, do you have any questions in the chat or?
Yes. I do have a question. I think that it was in the third slide. You were talking about sort of the time frame that you have, and you have put sort of in the years the roadmap of what you're developing. And you are talking. So the first question is: are you progressing in schedule? This schedule that you show, is still on track to deliver? And the second thing, it was in 2022, if I don't recall incorrectly, you talk about the implementation of the industrialization of BIM, and one of the things was the CDE, and you talk about an agnostic CDE in several cases. How are you actually doing an agnostic CDE? Agnostic CDE, do you mean open CDE, or I mean without a software? How are you doing that? Have you developed a CD yourself, or are you because at the moment we are struggling, you need to use a platform with a software that exists. So how are you doing that? And are you on track? That's sort of kind of two questions.
Okay. Yes. For the CD, the idea is not to create things by our own. We need to work with the ecosystem, with the value of the ecosystem to progress on that. It's not our job to have the specific development on that. We have a tendering process. We choose one is more open in the market, and we have more functionality on that. And we work deeply with the provider to have more functionality we need to achieve what we are intending to do. That is basically the approach. But the opening of the CD is one of the main KPI we use to choose the one we use now. So we need to do the CDI with the ecosystem, and we need a CDI that is connected to the more tools, authoring tools basically, but not only, to be able to transfer information more easily. We don't say that it's perfect, but it's help us now to go further and to reach our objective in how we can connect different kind of design coming from many different ecosystems, but also to go further. So the idea is not really to have specific CDE developed by own, but to take one open and to have more functionality on it to reach the objective of the open. I don't know if this answers the question.
So what you're saying basically is that the conviction is that you have an agnostic CDE that actually can, also the ideal will be that it's a CDE that can actually operate with different tools. And that is sort of the vision. And that is how you make the selection of your CDE. You go into the tender process with the view, we want a CDE that fulfills this sort of vision. But obviously you are using an authoring CDE, right? You didn't develop one yourself.
Yes.
Okay. And are you in schedule with this strategy that you have until 2025? And what are the learnings so far?
Yes. The first one, by the end of this year, is not really linear or sequences. Is mainly we put the effort now, first of all, to have the capability to develop and to deliver what we need to deliver when you have some railway projects. That's the first issue. And how to engage all the people who are involved on that. And industrialization phase means we need to have a generalization of tools, generalization of BIM using BIM mandate at SNCF level. And it means also the generalization connected all this to the IT system in place. So that is some work is ongoing. We have many work on that. We have many projects on that. The idea is not to make a BIM that is something different from how the real system works, but to connect them really to be sure that BIM, with his capability, his capability to bring some more info to have the system under control, to put it in the real system to have more performance on the system. So this need to connect the approach, the people who are on these phases, the people who use this system using directly the IAT system. So we need to connect them, to connect the database, and to also to engage the update of the system using information that can probably come in from the CDE.
Good, thank you very much.
You're welcome.
Okay, thank you very much for your presentation. It was great. Thank you. Okay, then we jump to the second presentation. We jump to Portugal. Metro for Portuguese, Mind the Gap on Portuguese Open BIM scenario. And Mr. Jose Lino. Are you virtually there? No. We don't have a presentator and we don't have files, so I think we don't have a presentation. But do we jump to the next one? Okay. I think, Mercedes, you cannot see anybody there virtually, no?
No, exactly. No, and I didn't receive. I mean, I was told that all the presentations were on site today.
Okay.
So there shouldn't be any, virtual.
Okay. Then I think we will jump to the next one. 5 minutes. Okay. Okay, we will have a 5-minute break here, and we continue in 5 minutes. Okay. Do you want more questions for Judical? We have the second presentation, The Road to AIM by Systra and Mr. Louis-Marie Borione and Mr. Lucas Gibord.
Thank you. Okay, so my name is Louis-Marie Borione. I am in charge of innovation program development at Systra, which is called Dev4Beam, and I'm here with Lucas Gibord, who is a Beam solution developer. So maybe everyone already know about Systra. So Systra is a design company all over the world, delivering a project dedicated on the rail industry. I skip directly to the different objective in terms of the innovation and the scope of my team, Dev4Beam. So we are developing application on several parts of the Beam aspects. So we have 5 dedicated tools on different use case on the Beam to automate the creation of Beam data, to control the quality of Beam data, to enrich the asset information model, to use the data to assess the carbon footprint, and also to have applications to control the technical risks. Today our presentation will be focusing on 2 of those tools, Elodie and Pablo, to demonstrate how you can use those tools to develop an asset information model. So our presentation will be mainly to present what is the asset information model, show you our solution, how we imagine the way a designer produce an asset information model, and lots of videos to demonstrate how the tool is used. So what is an asset information model? The end goal is to be able to build a digital twin. So to be asset-centric and to centralize every part of the asset, from the design, the as-built, to connect this to the IoT, to connect this to asset management systems, etc. But as for the Beam levels, the road to a digital twin can be complicated to go from what we are right now at, would say, level 0 of a digital twin, or maybe level 1. We can imagine those different steps on what is the path, the road to digital twin. So what we have in thought is that as Beam level 0 is kind of no Beam, we could say that the digital twin level 0 is no digital twin. So just the as-built record with paper, you deliver to the client at the end of the project a set of documentation. Then you could have the level 1 of the as-built record, which is no longer paper, but is the result of all the Beam models and the 2D drawings that come from the design and build process. And this is mostly where we are right now. And we imagine that our goal is to be delivering a level 2, an asset information model. So you deliver all the Beam models from the design, from the build process, but also a dedicated asset information model who centralize all the aspects of an asset which will be needed for the client to operate and maintain this asset. And this is just before going to what we could be called the level 3 of the digital twin for the future, an integrated digital twin with every aspect. Right now, we want to focus on something that is more achievable and not seeking for something 2 steps ahead, go one step by steps, go from what we are doing right now, level 1, to what we do on some project, the level 2 of the road to digital twin. So to really understand what is the purpose of the asset information model is to be able to, as I said, centralize and structure the information that will be required for the operation and maintenance phase. So it could be, for example, a list of equipments, total maintenance cost, record of installation and maintenance dates. Those kind of data right now are not in our BIM model. In our BIM model, we enter design information, we enter construction management information, but not those kind of information. So what is our solution and what will we see? For this, I give the microphone to Lucas.
Thank you, Louis-Marie. So we will now present how we have chosen in Sistra to answer this problematic of created an asset information model. So as Louis-Marie explained earlier, our idea is to respond to this problem by meeting the needs of our production teams and those of our customers by proposing a pragmatic and flexible solution that can adapt to the project context. So we will present you the complete process of building an asset information model on a project and also the tools we use for each step of its constitution. So to do this, we will take the example of a conventional railway line project and explain the 3 major steps necessary for the constitution of the asset information model. The first step is the construction of the data schema. The data schema will allow to define the data requirements that will be expected on the project. This will allow us, for example, to define the expected data on the assets that have been explained by Louis-Marie, but also the definition of the data expecting on the objects. The second step will be to control that the requirements we have defined through the data schema are well implemented in the BIM models. In addition to the control, of course, it's very important to be able to communicate and share the results of this control to the production teams in order to reach a maximum level of compliance before building the asset information model. And finally, the last stage is the constitution of the asset information model itself by using the project information model. It means that once the BIM models have been checked in the step 2, we will have to build from the data they contain a database containing all the asset management requirements. This database can be then processed in different ways and re-injected into the models. But I will let Louis-Marie explain that in detail.
Okay, so first, the goal is to build something that we call a data schema. It's the list of all the property, so to build a property dictionary, the property sets, and to list then all the asset type you have on your project and the object type you have. By object, it's more related to what will be inside the project information model, and the asset type, what you expect to be in the type of object you expect to be in the asset information model. So how do you do this? So this is our tool, Pablo, and we'll start by entering a property library and to create some properties. So here I have some already existing properties like owner, name, type, material, length. Those are properties that you expected to find on object in the project information model. And I'll add a new property, let's say unique asset identifier, UAID. And this, you will be expected to find this on the asset object in the asset information model. So you have to enter some fields on this property. Then from here, you will be able to create what we call the object type and the asset types. So here, for example, you have a structure of objects that you expect to find on your object in your project information model or in the asset in your asset information model. So here I'll create a new item to say, for example, I expect in the project to be some viaducts, some bridges, some elements, and inside a viaduct, for example, you expect to find some piles. And once you've done this, you can list the properties that you expect to find on an object. So here I add the asset, the unique asset identifier. I said I want these properties to be added to every object that are of the asset type. So by doing this, you create a data schema that lists every type of object you expect to be in the project information model and the list of all properties that you expect to find on those projects. And also on the asset information model, you list all the asset types that you expect to find and all the properties you need on those objects. And from there, you transfer this information to your design team, so the list of objects. They build their design model, and then at some point you need to check that the project information model meets these data requirements, and for this I give the mic to Lucas.
Thank you. So the second step in our process is to ensure that, as explained by Louis-Marie, the BIM models built in the project information model comply with the requirements that have been described in the data schema. So if we take the schema presented by Louis-Marie just before, we have to ensure that the data contained in the project BIM models, which is the PIM data, is compliant with the requirement described by the data schema. So in order to check these requirements, we have developed a BIM model checker application called LOD. LOD is a web application that allows the user to get the data schema for his project and to use it to control the project information model. So now let's move to the application for a quick demo of the functionality of the tools. So when you are in the application and you have loaded your model, the first action you will want to do is to load the configuration, which is the data schema. So this configuration is stored in an Excel file, and as soon as you have loaded this configuration, the result of the checking will be displayed on the application. You will have in red all the objects that are non-compliant with the data schema, and in green all the compliant objects. So then when you have launched this checking, you will need to get a deeper understanding of the control. So you will use the first tool to have a global vision of the results. So on this tool, you will have the number of control points that have been made in the model, the percentage of the control points that are validated. In the section just below, you will have a very interesting section where you have the most frequent errors that have been found in the model. So what we can see, we have a first property, FRP_type, which is missing in approx 81% of the objects. The second one is another property, FRP_non, which is wrong in approx half of the object of the model. Then you will have other figures. Here you have the object figures, so you have the number of objects in the model, the number of validated objects, the object with missing properties, the object with blank properties, and finally the object with wrong properties. So it means where the value of the properties is wrong. Then we will have a very important section, the section about the classification. So classification is very important because it's the way we will recognize the type of the object inside the BIM model. So we will have here the figures of the check according to the classification. We can see here that it's quite good because 100% of the objects are well classified. We have also the number of classification. And finally, you will have the first detailed results. Here are the results on the file. So you have the codification, the file size checking, the unit checking, and then finally, the IFC structure checking, where we will check all the properties of the IFC project, the IFC site, and the IFC building. So this is a tool to analyze the results globally, but then you will need to go deeper into the detail to understand where are exactly the issues you have in the model. So for that, we have another tool, which is a table. And in this table, you will have the list of all the control points that have been made in the project. So we have talked earlier of a property which is FRP_non. So we will filter the control points by the name of the property, then by the not validated control points. And we have on the first line one issue. This issue will be on this object, so it's a pile cap. And we can see that in the value we have an error, and in the name we have 2 underscore instead of only 1 in the values that have been expected by the data schema. So once we have analyzed this data, it's very important, as I said earlier, to be able to communicate and share these results with the production teams. For that, we can export through LOD in 2 different formats. The first one is the Excel format. So Excel is a very easy format to share across all the members of the project. So you can export the reports, which will be basically what you have in the application, but stored in an Excel file, so that you can store the results of the control. And the second option for the export will be to use the BCF format. So the BCF format is an open BIM format to share comments we have on the BIM model, and it will be attached to objects. So we can export all the results on this BCF format, and basically we can use later this BCF format to integrate the comments directly in the production software. So this is the last step of the demo. We will use directly in Revit this BCF format to get all the controls that have been made in LOD and to directly correct all the inconsistency we have seen. So here we have one of them, and we can see here that we have an issue on the property FRP_non. We can have the expected value, and then we can go on the properties of the object to change to the correct value. And once the model has been corrected, we can, of course, re-upload the model in the application to check if now the model is 100% compliant.
Thank you. So what we've seen so far is how you can define a data schema to check if your project information models are compliant with this data schema. And then we'll see how we can build the asset information model from there. So we go back to our tool, Pablo. So same as LOD, a web tool dedicated to build the asset information model. And we'll show you. So we stopped there where we created the list of object types that you have in the properties. And he has made a small modification on the assets. No, here I create a new asset. So let's imagine that Lucas submits his bridge that we see earlier, and we want to create an object that will be supporting the information on the asset on the level of the overall bridge. So we need to create this in the application, an asset that we called FRP viaduct, if I remember well. And we can add the properties that we were expecting, not on the object side, but on the asset side. So we enter manually. I think it was a unique asset identifier and a lens. And then you can open the model. So it's the same bridge as Lucas showed. And start do what we call the painting of the model. So the painting is really to say, so on this bridge, I want to identify that, for example, that all of the files that are individual components in the project information model, I have maybe something like 20 objects with different properties, different lengths, different maybe material, I don't know. The concrete grade could be different on some of those objects. But in the asset information model, I don't want to go too deep in this detail. I want to define a new asset, which will be the foundation system. And the foundation system does not exist in the project information model. So we create here and we say all of those objects that are in red are one asset, which we could call the foundation system. And then in the data schema, if we define an object that we call the foundation system, we have the list of all the properties that we want on this object. So let's say, for example, the lifetime expected lifetime. And by doing this, you reorganize all the information that are stored in your BIM models to build something that will be able to be transferred to your clients, to his asset management system. So this is the last part. So in conclusion, at the end of the process, you define your properties, you define your object type, you define your asset register, is where you list all the type of assets. You build your asset information model by reorganizing the data of your project information models, and all of this data can then be transferred to the client in this asset management tool. Thank you very much.
Thank you very much for a great presentation. Do you have any questions from the audience? Mercedes, do you have any questions from there?
Yeah, I do. Just looking into how you put the asset information model, and in terms of you're talking about the lifetimes of these both models. So the project information model you would do as you are building the project, as you're doing, so it's, let's say, a lifespan of 2 years. But the asset information model you are going to use, you know, if everything goes okay, for 50, 100 years. How do you go about doing this model that it is flexible enough to incorporate things that you, at the moment, you don't know that are going to exist? Because as the life passes, there's going to be things that are going to be invented that you really never thought about that they would exist. And I'm talking about, you know, maybe 20 years ago, you never thought about having all these sensors that we have at the moment. So how do you keep the flexibility in the software?
I will try to rephrase. So the question is, how do we manage, once we have created the asset information model, to maintain it and to make it, to have an evolution on it? So basically, what we are building is not an asset management system, is to build the asset information model. And then we will deliver this asset information model to our client. And the client will use this asset information model in its own system to maintain and to make it, to have an evolution on it with the time. Basically, our goal here and what we present is how we can, from the project information model, create an asset information model that we can deliver to the client. but then the client will be the owner of this asset information model for the rest of the lifetime.
But with the owner, we have the capability to actually amend the asset information model. So you know, when I was looking into creating a new asset and then assigning all the properties that are likely to be there, you have to program all those things. The owner will have to be able to program to cater for properties that they don't yet exist.
So yes, in this tool, the asset information model is still editable. So what we imagine at some point is this asset information model was the responsibility of the construction or the design and build team, or the people that are involved in the creation of this asset information model. At some point, when it's delivered to the client, you have a transfer of ownership on these properties, and then if the client wants, he could still be using this our tool to still be able to edit the asset information model. But this is really more a question of ownership of the data and in different stage of the process, who will be in charge of populating information or creating the information.
Thank you. We have one question from the audience.
Hello, thank you for your presentation. So I have a question. Just in your asset information model, if you integrated the dynamic component like sensors to update the information data or properties for your project, your bridge in each phase of its life cycle. For example, in our company that we do, we put sensor to monitor a lot of project, tunneling or a bridge, road, etc. If you can, I don't know if you have already tested this sensors in your to update in real time your information in your data set.
So we see this tool ready to be used during the construction phase, before all the data is transferred to the client and the asset is delivered to the client, the physical asset. So at this stage, we have very few IoT that are used, because during the construction site, you don't put a lot of IoT on your object that are connecting and measuring information. So we don't have this right now in our mind, but the goal later is to be able, in the client asset information system that he be used, to connect the IoT to an asset that we define in this tool. Mostly in design and construction phase, yes.
Okay, thank you. There's other question? There is one question from audience here.
Sorry, it's not a question, maybe more, I'm working with these guys, maybe more an answer to the first question. The information hand back for the asset information model to the client is a key issue. And what you said about how we hand back this information is very important. What we try to do is to have a database of all the asset information that we can give to them, which is quite agnostic, a database, you can use it. And it's also their duty to be able to integrate this in their information systems. Some of them are already having this kind of solution, but not all of them. Of course, the solution can be used to help them to carry on and to ensure that this information remains consistent with the reality of the asset after when you maintain it and when you operate it. And the second part is, so we will have this asset information database, and also all the BIM models will be all objects identified with the unique identifier of the asset. so we know to which asset is related. So with this, we give them the basis to start to build a good referential of their digital twin. But it's not the complete digital twin. Of course, then you need to connect all of this with the hot data source like IoT and so on.
Thank you. Any other questions? Mercedes, do you have still questions there?
Just one last one. So obviously, BIM is really is obviously common practice nowadays in when you're doing the construction. As you say, the handover is always has been historically, and it is still a bit problematic. And this obviously, it is really good just to have a good base for creating an asset information model. So where do you think, what are the tips for starting the process, and which point will you start this asset information model? Just as you are developing the project information model, a couple of years before you hand over, when is the right time, in your view, to start this process of creating the asset information model, and not to leave it for the last minute when you need to hand over the process?
So I think the best tip is the sooner the better. The sooner we can start building the data schema and the requirements we want for the asset information model, the better it is, because when you will start your production of the BIM model, you will start defining the properties you will need for the asset information model. So yes, I think the only tips we can give is the sooner we start this definition with the client and with all the team we have in the design, the better it is.
With one comment is that this asset information model and the data schema can be evolutive. At the beginning of the project, you can add very few properties, just identify some basic assets, and during the design to go more deeper and structuring a more complex asset information model, but at some point to really have a global overview of what the asset information model will look like, and then during the design and construction go more in detail.
Okay, thank you very much for your presentation. Okay, and then we have the last presentation, leverage BIM to improve low carbon railway infrastructure. And you are continuing the presentation, so we don't have to introduce the presenter now.
Okay, so welcome to this presentation. During the next 20 minutes, we will try to show you how we use BIM data to improve the low carbon railway infrastructure design. I am Eric Prévost, in charge of digital engineering at Sistra, and I will do the presentation with Lucas Gibault, who is the product owner of the carbon tracker. Climate change is a reality, And it is our duty as individuals or companies to ask ourselves what we can do to improve the carbon emission reductions. As rail and mass transit transport designer, we thought for too long that it was sufficient to state that because of the positive impact of public rail transport, we had nothing to prove on this matter. Even the innovations, such as the U-shaped viaduct that you see on the screen, were not initially evaluated for their environmental benefit, but mainly for their cost benefit. So can we do more? Of course, the question is, yes, we can do more. And I would say, yes, we have to do more. At Systra, do more meant shifts from a qualitative approach to a more quantitative and systemic approach in regards to carbon emissions. And the question is how digital, and more precisely carbon tracker solution, can support these objectives. In fact, carbon tracker allows to take benefit of the BIM data we're creating on the project to provide information to all the project stakeholders about the impact of the CO2, I don't know why it's moving all the time, sorry. To provide information of the decision they're taking on the carbon footprint on their asset, and this during the design process. In other words, the solution will provide information to the designers about their decision and the impact of the decision, and on the other side, it will provide to the client, to our client, all the information they need to monitor and track the evolution of the carbon footprint of the asset they ask us to deliver. So to develop Carbon Tracker, the main challenges we faced was to capture the data and make sure this data was relevant and understandable by our algorithm to calculate the CO2. And this for any kind of infrastructure, any design phase, and also any data format. As we could not rely on OpenBIM standard when we started to develop the solution, we had to find a way to go around this difficulty by implementing some configuration rules that you will have some overview during the presentation, the demonstration. And the second point of this, is also to ensure that the quality of this data is checked and verified, and we have reliable input data to do the calculation. So before giving the floor very briefly to Luca and after to the presentation, we're sorry we can't do a live demo because technically it was a bit difficult, so it will be recorded. But I would like to highlight that the CO2 calculation that we're doing in Carbon Tracker is not only the quantity materials evaluation, it's of course a long whole life cycle assessment of the carbon emission.
Thank you, Eric. So as mentioned by Eric, it's very important to integrate the sustainable design and the carbon management the sooner we can on a project. In order to do that and to help our designer in their choices, we need first to quantify the carbon emission at the early stage of a design in an efficient way. For that, over the past 2 years, we have developed a tool named Carbon Tracker, which enables a carbon estimation based on the project data. Then, once we have quantified these carbon emissions, we need to control and analyze their distribution and values over the project. That's why Carbon Tracker provides tools for the designer to analyze the carbon distribution on the project in order to help them designing low carbon infrastructure. So for the next minutes, I will show you through a recorded demo how we can directly do that in the application. We will first start with the integration of a new BIM model in the application, and we will analyze the result over the project. And finally, we will try to mitigate the carbon emission of a project by using a variant management tool we have directly in the application. To connect to the application, you just need to go through any internet browser, because the application is a web application. So you just need to connect with your Sistra account, and you will be redirected on this page, which is called the project up page. So on this page, the user can activate one of the projects that are available in the application using the activate button. As soon as the user click on the button, all its action on the application will be on the selected project. So in order to integrate a new model in the application, you just need to go to the model playground page. So the model playground page is the place where any user can upload data in the model. So in order to add new file in the application, you just need to use the drag and drop zone available here. So let's make an example. Here I have 5 BIM files. I just select them and drag them in the drag and drop zone, and automatically the file will be uploaded to the application. So as soon as the files are uploaded, the application will convert them from their input format to a specific format that can be viewable on a web browser. So that's what the software is doing right now. And as soon as the files are ready to view, they will move from the right side of the screen to the left side. As soon as it's okay, you can click on a file to open it and start the analysis of the model. So I can click on the file. It will automatically open the BIM model viewer. So here is the BIM model viewer. So you have all the basic functionalities of the BIM model viewers. You can, of course, select an object, view its properties. You can also navigate through all the data of the model. And we have extended this viewer with some specific functionalities for Carbon Tracker. So this is all the buttons you have on the left side of the screen. So the first action you would want to do when you open a BIM model is to check if the BIM model is compliant with the requirements you have on the project. It means if all the objects of the model can be taken into account for the carbon calculation. So for that, you just need to click on the first button and click on this button, apply. And automatically, all the checks have been done on the BIM model. And you have on the screen all the objects that are compliant in green and the object with the inconsistencies in blue. So for example, this object have the asset tag parameter missing or the classification parameter missing. So the other functionalities that we have here in Carbon Tracker will help you to analyze the result of this check. So let's select the first one, which is the model analytics. It will give you some figures about the check. So we can see here that we have the number of the control points that have been made in the model. Here, this section will give you the most frequent errors that have been spots in the model. So for example, here the property category, which is the properties that is used to get the classification of the object, is missing in approx 18% of the object. And if I click on the rectangle, it will let me at the screen only the object with these missing properties. So it will help a lot the person who is checking the model to understand what are the inconsistencies. And of course, you have a lot of other figures. For example, here you have the object figures, then the asset figures, and finally the classification figures. So the same way, you can click on the graphic and it will change what is displayed on the screen. So the classification is a very important topic because it will allow the software to make the link between the object and their types with the database of carbon tracker of all the project components. So unfortunately, I will not have the time today to show you all the functionalities of the software to analyze the results, but it's worth to mention this one, which is the export control report functionality, because it's quite important on a project, because it will allow the user to share and communicate the result of the checking. So we have two different formats. The first format is Excel, which is quite easy to share on a project. Everyone can open an Excel file. And the second one is a BCF format. So the BCF format is an open bin format that can be easily integrated in all the BIM production software. And you have the commands which are linked with the objects. And finally, the last functionality of the viewer is to export all the quantities that have been taken from the model to the database for the carbon calculation. So in order to do that and to have a double check of what will be taken, here you have a table of all the data that have been taken from the model. For example, if we look at the first row here, we have a pier, and we can see that this pier is approx 81 cubic meter of concrete. So this value will be taken and sent to the database for the calculation. So as soon as you are happy with the data, you can just click on export, and automatically all the quantities of the BIM model will be sent to the database of the application for the calculation. So now let's move to the results. So in order to see the result, we can see them at the project level. So for that, we can go to the cockpit page. So the cockpit page is a dashboard. Of course, this dashboard is composed of several sections. So you have on the top left side the big figures of the project. For example, we have 233 assets. Here is the number of objects that have been taken into account for the calculation, the number of files, the number of object types. Here you have the result in terms of carbon emission on all the life cycle. So if you, when we analyze the project, we decompose the result in several life cycle stage. So the first one here, A1, A3, is for the production of the materials. The second here, A4, is for the transport of the materials from the production site to the construction site. Then you have A5. A5 is for the site activities. Then you have B2, which is for the replacement. You have B4, which is for the maintenance. B6 for the use. So it means if there is any energy consumption from the objects that you have in the project. And the last one is C1 for the end of life of the object. So if the asset, for example, has to be disconstructed. At the bottom of the screen, you have the graphic to display the result in terms of asset types. So each bar here represents the amount of carbon emission for each asset type. For example, here we have the amount of carbon emission for the viaducts on the project. And of course, it's linked dynamically with the pie chart here. So as soon as I will put my mouse over here, it will automatically change the result on the left and change the table of the result on the right. So on this graphic, we have two views. The first view is the carbon. So this is the result for the carbon emission. But we can also have the result in terms of tonnage of materials. So if we click here on the truck, automatically it will switch from the carbon emission results to the tonnage of the material. And for example, here we have the result of a ton of concrete for the project. The last two things to mention on this dashboard is firstly this section here, the emission reduction. So in Carbon Tracker, you can basically define a project baseline result in terms of carbon emission, and then this will allow you to compare your current result with the baseline. We have set a baseline with the client, and we try to have a design that is less than this baseline. And the last section of this dashboard, is the target year slider. So as you can understand, all the results you have here are related to an hypothesis that has been taken on the project life duration. So here, the results are displayed for 120 years after the construction of the project. But of course, we can check the results, and it will be different if we check the result directly after the construction. So this is how you can view your result at the project level, but you can, and you will need to go much more in details in order to analyze where are the hotspots of the carbon emission. So for that, you can go to the project analysis page, and you will have a very specific graphic here. This graphic is a hierarchical pie chart. So it's composed by several levels. So the first level of this pie chart shows the distribution of the carbon emission across the different asset types we have on the project. Then we can enter in, for example, the viaduct, and we will have in the second level the asset instances. Then if I enter to one of the viaducts, for example, this one, we will have the third and the fourth level. So the third level will show you the distribution of the emission across the different category of objects. For example, here we have 36% of the emission of this asset, which is from the concrete, and 74% of the emission that is from the steel objects. And the last level, which is the more detailed one, is the object category. So for example, here we can see that on this specific asset, 53% of the emission are made from the plate girder. And of course, at the center of the graphic, you have the amount of carbon we are looking in the graphic. And here, the percentage is the percentage of this value across all the emission of the project. So let's go back to the root of this graphic at the beginning, and let's switch the parameters to understand what is the distribution over the object types in this project. So we will change the level definition to move the component category and the component types at the beginning. So it will automatically recalculate the graphic. And we have here the distribution now across all the object types on the project. And what we can see is that the foundation components have a big impact on the project. For example, here, the ground slab concrete in situ is approx 10% of the carbon emission. You have here the diaphragm roll, here you have the pile, and so on. So what we will try to do this is the last part of the demo, we will try to reduce the carbon emission of this project using a less carbon emitting concrete for the ground slab concrete in situ. So for that, we will use a concrete for this element where the cement is replaced by 70% of blast furnace slag. And we will compare the two variants. So how we will do that? So we will go back to the project configuration. And before doing any change on the project, we will store the current state of the project. So for that, we just need to create a new backup. So I will give this backup a new number. I will give a description before changing ground slab concrete. And automatically here, if I save, it will save
all the state of my project. So now I will move to the project components in order to change the concrete of the ground slab concrete in situ. So I move to the third page. Here are the ground slab concrete in situ. So I edit, and here I change the concrete from a 0% replacement concrete to a 70% replacement concrete. And as soon as I click on the button save, automatically Carbon Tracker will recalculate all the results of the carbon emission for all the project. So basically, it will go over all the objects of the project to see what are the ground slab concrete in situ object, and will recalculate the carbon emission of all these components. So normally it should take approx 20 seconds. And once it's finished, we will be able to go back to the analysis tool to compare the two versions of a project. Yeah, so it's finished. We can now go back to the analysis tool. And I can activate the compare tool. I will select the previous state, which is this one. And what we will have on the screen, we will have on the left side, the current state, and on the right side, the previous state where the cement of the ground slab concrete in situ object is not replaced. So we can see in terms of result, we have a huge impact in changing the concrete. So the last thing before leaving the floor to Eric is I will switch the level definition. And we can now see that the percentage of the emission of the ground slab is going to 9% previously to now 5%. So thank you. That's all for the demo, and I will let Eric to conclude this session.
So this I will do it live. So yeah, it's time to conclude the session. If we can go back, no. Okay. So the purpose of the presentation was to highlight the potential of BIM data to overcome a business case, here the CO2 emissions, and show the power of managing the data on our project. We are engineers, and the contractor likes to tell us that for many times that we were only producing paper and not building anything. But now we're not producing paper, we're producing data, and this is the core materials we have to manage. And this is our strategy as Sistra, to be able to manage this information, which can create a lot of value for us and for our clients. But also the purpose was to share and to say that we are convinced that the open format and open data will help us very much to grasp even more benefits on this data that we're creating by offering more data continuity and data which is more interoperable between all the solution we have. So thank you very much for your attention.
Okay, thank you very much for presentation. Great presentation. Do we have any questions from the audience? Silent here. Do you have, Mercedes, any questions from virtually?
Yes, yeah, I do have a question. So looking at the presentation, you are able now to redesign the project to improve the carbon emissions. So you can say, okay, this is what can I change to improve the emissions against a baseline that the client will give you. Do you think that in the future you will be able to also evaluate different tender proposals based on the proposal that give you the least carbon emissions. Because as you show in the demonstration, it's not only the materials that you use, but it's also the transport of materials. And different contractors will have different stake of where are they taking the materials, where are they, how is the logistics of the construction. Do you think that that will be used as a base for tender evaluation in the future?
Thank you. Yes, it can be used for tender evaluation. We have not shown one part of the solution, which is the GIS part that we use to evaluate the transport emissions. We have two ways to evaluate the transport emission, in fact. At early stage, or when we are more on the client side, we have requirements. And for example, we are talking about baseline, but what are as a client, our objectives in terms of optimizing and reducing the transport? For example, we can say in the application, we don't want the concrete to come further than 20 kilometers around the asset. And so we set all these requirements and we calculate the baseline, maybe for a tender, to say this is the baseline of the evaluation. Then when we receive a tender, if we will have in the tender, of course, all the requirements in terms of BIM classification and data organization that we will ask the contractors or design build to follow. And then we will import all this BIM data in our solution, and we can run and test what are the result of this. And for example, you're talking about the best way to do it is to give access to the solution to the contractors and the tendering parties to do their own evaluation and to say, okay, on my side, maybe I go a little bit further to go for the concrete, but I will do other things that in the end will provide a better CO2 impact on my project. So we need to give access to and let people show what they can do and not be too strict on the way we contract and we tender. But and that's the power also of web application and this kind of application is to be able to share and the information to all the stakeholders.
Yeah, exactly. Also give the data so that people can actually make their own decisions about how they can maximize or in this case minimize the output actually of CO2, carbon dioxide. Thank you. Not sure if there is another question. I actually do have another one, but maybe if there is another one with the audience.
Is there any audience questions? No questions, so go ahead, Mercedes.
Yeah, well, it is a really, actually, we were actually talking this yesterday that many cities and many owners obviously are actually going into having this baseline, is this sort of building to the strategy that we want to be carbon neutral by this year. And obviously going into the future, it will be very, very important to be able to track the carbon. What are we doing in the operation? Because obviously the operation is the longest period. And what are we doing with the reuse? Now, in last year, the UK launched the carbon reduction code. And I was just wondering, is your development in accordance to this, or are you following any particular standard with your software?
Yes, the way we are calculating the carbon emission and the way we provide the result is following the ISO norm 14040 and until the 44. So yes, we comply with the regulation and the ISO norms. And basically, we have based more of the application on the way we are managing the carbon on UK projects. And then we have extended the application with specific functionalities in order to be flexible on all the projects we have all over the world.
And also one key point in this flexibility, we work in a lot of different environment countries with their own CO2 database emissions. So we are not fixed. When you start a project, when we identify for each component the emission factors, we do it locally based on the local regulation, and you build this for the project. And the good thing also is when, as the time goes, you build up also your database and your knowledge around the carbon emissions. And that's also maybe a point that we didn't highlight there, is by having this structure approach and being able to have these results and to archive this, we will use the results also to have maybe ratio and to improve the baseline when you don't have a lot of information at the start of a project, to use previous project to have more precise baseline and better objectives for the carbon emissions.
Good. And do you think that in the future, when you're talking about in operation, because that is quite an important one, do you think that in operation you will have real data? You will be, or is the vision that you will have loaded real data from sensors, and you will be able to estimate or to calibrate your model as you go when you go into operation?
That's the next steps.
The
first one we would like to go for is for the construction. As I said, the application is also there to help our client to monitor and control, because we're convinced that in the near future they will have much more engagement to take towards their own community in terms of an allowance for carbon emission. You're talking to meet the objectives. So they just can't say that we do our best. They need to prove that the asset they're building, of course, will serve the community, but also will protect, will meet the objectives. So with this, we can do it during the design, providing more information around this. We have solution where we look also for the transport activities, which are quite a large amount of CO2. So the application can give the requirements, and every actors after contractor knows what we use to define the baseline, so they have the good information. And then we want to use GIS. We have some trials we had already to really monitor the traffic of the contractors and so on. So and really to bring back this information and compare to the design. So this is the next step we want to do.
Good. Thank you very much.
Thank you. Any questions, audience? No more questions, so I thank you very much for Eric and Lucas. Yeah. Okay, thank you. This session is now over. We missed one presentation, but we had more time for discussions. So thank you very much and enjoy your rest of the day. Thank you, Mercedes.
Thank you. Ciao.